Okay, so first things first, we're going to go for a review of quadratics. And what I want to do is just sort of walk through the booklet, reminding us what we've done. Sorry, not to make you seasick there. And, um, and then we're going to do some work. So first, we made charts, which we're not making anymore. Hang on one second. And we graphed things. And we saw that when we make a graph, that we need to have a title. We need to have an arrow on our vertical axis with something labeled, our units, and what it is, money, pounds, whatever it is. And then here, on the horizontal, we need an arrow. If it's applied math, we have the words. If it's pure math, we just have X and Y over here and here. And we have some scaling, so we know that each tick is 1 or 2 or a half or whatever it is. And then here what we did was we did some interpolation and some extrapolation. So when we plotted the points over here from our chart, if we were asked to find a value in between two points that we plotted, we would go in between and just guess based on the trend that we saw attaching this. So if we know the y value here, for this x value, if we know the y value, and for this x value, we know the y value, and this one, and this one, and this one, if we're asked to find something in here, or here, or here, we can just guesstimate it to be about that, right? Okay. Extrapolation was when we went beyond. So if we only have points from here to here, if we were asked to find out what this would be, or this would be, or this would be, any of these x values, or any of these x values, if we were asked to find the y value, given whatever x value they asked us, we would do extra. We would go extra outside. So, next, we did more figuring stuff out and plotting. And we learned about that. This is called, when the curve looks like this, which is not what this looks like, it's called concave up, and the vertex will be a minimum. And when it looks like this, it'll be concave down, and the vertex will be a maximum. Right? No surprises there. We then learned that not all curves go up and down. Some curves just go up, like exponential curves. Some curves go up, up, or down, and those are quadratics. Okay, here we looked at sort of looking at a graph and getting information out of the graph. So for example, here, in order to get the most money from a group, how many people or members should the group have? So we go to the money, the most amount is up here, and then we look at how many people there should be. And then what was the maximum? So we go up here and then we say what that number is, the maximum revenue or money coming in. And then what is the revenue from a group of 20? So revenue is Y, and group of 20 means 20 people is X. So basically they're saying when Y, what is Y when X is 20? So we go to 20, we go up here, and then we find out what the Y value was. We said approximately $800. Then what happens at 0 people and 100 people? So we looked here at 0 people and at 100 people. And then what happens after 100 people? And we talked about that also. Okay, so what we're doing is we're looking to see in these applied math problems, what do all the parts of the graph mean, and look at all the information we can find out from a graph. Okay, so then we talked more, and then this was the exact same thing. We just found out different things about the graph, what it told us, and then we also learned about the expression break even. So break even is when the money going out is the same as the money coming in. So you invested $5,000 in your business, you are out $500, you do not have a profit, you are $500, as they say, in the hole or in the red. Because in the olden days when they did their accounting on paper instead of on computers, they used a red pen if you were out of money and a black pen if you were making money. And when you have a business that costs $5,000 to start and you have brought in $5,000, then you have broken even. Now, of course, ongoing, there'll be other things, like even though you spent $5,000 to start, then the next month you spent $600 on electricity and employees and other things. But when the money going out, all the money is going out, all of them, not just the startup, but all the money is going out, equals all the money that's come in, you are broken even. You are no longer out of money. You haven't made any profits yet, but you're gonna, unless you change your business strategy to something that's not working. Okay, then we looked at the parabola and we really focused on what the axis of symmetry is, which is that vertical line that goes through the vertex. What are zeros, which are fancy words for x-intercepts. Y-intercept. Optimum value is the y value at the max or the min, or the y value of the vertex. And then we looked at all of this stuff. And then we did a bunch of practicing. We said, okay, here's some parabolas. What's the vertex? What's the optimum value, which we know is the y value? What's the axis of symmetry? There's a x equals. You don't just say 3, it's x equals 3. What are the zeros? There will either be none, 2, or there could be 1 if the vertex is on the x-axis, right? Okay. Then we had some true and false, direction of opening, y-intercept. To find the y-intercept, we let x equal 0. To find the x-intercept, we let y equal 0. Then we did a bunch of parabolas. I gave you information, like I said, graph a parabola that has vertex this, opens down, and has 2 y-intercepts, and you graphed it. And that's what we did. Then we did more applied word problems, again, with these graphs and answering questions. Then we looked at vertex form, and we know that when we have vertex form, hold on a sec, let me take a step back. First we looked at y equals x squared as our main parabola, and we learned about over and up from the vertex, over 1 up how much, over 1 up how much, and so on. And if this was positive, it was up, and if it was negative, it was over and down. And then we did some investigations, and we found that when we plotted all of this, we noticed patterns that when you have y equals x squared and then it's down -3 or +2, it just means take all the points in y equals x squared and move them down 3 or move them up 2. And then we did the same thing but moving right and left. So we did more investigations, and we found that when the number's in the brackets, we move right and left. And then we did more investigations, and we learned about the over and ups and how when there's a number in front of the x squared, the ups or downs change. Like over 1 up 1, over 1 up 3 became over 1 up 2, over 1 up 6 for y equals 2x squared, over 1 up 3, over 1 up 9 for y equals 3x squared. And then we were given a bunch of parabolas, and we had to fill in all of the information, make sure that we knew what we were doing. And here we learned about vertex form and how this will tell us what the vertex is. So we do the opposite of this, -1, or another way of looking at it is what makes this bracket negative. And then what makes this bracket equal 0, so -1 + 1. So -1, -8 would be the vertex. That's going to be over and up because it's positive, and over 1 up 2, over 1 up 6. And then we graphed all of that. We did more word problems. We've done a lot of work here, huh? We did more word problems. And then we also learned about factored form and how if we factor something, we are going to write the x-intercepts, and then the middle value will be the x value of our vertex. And then we take that x value, we plug it into our equation to find the y value of our vertex, and then we look at the over and ups or over and downs to make sure that we've lined up everything. And we did lots of practice with vertex form and factored form, and that was Unit 2. So here's what I want you to do now. I want you to go to this page here, which is 228, and I want you to do column 1, the first column and the second column.